What is probability distribution? Assume that a fair coin is tossed 4 times. What would be the probability distribution of a variable x, which represents the number of tails in 4 tosses of coin? What kind of probability distribution is this? Justify. What is probability distribution? Assume that a fair coin is tossed 4 times. What would be the probability distribution of a variable x, which represents the number of tails in 4 tosses of coin? What kind of probability distribution is this? Justify. Probability distribution. A probability distribution is a mathematical function that describes the likelihood of different outcomes or events occurring. It provides a mapping between possible values of a random variable and their corresponding probabilities. In the context of the fair coin being tossed 4 times, the variable x represents the number of tails in those 4 tosses. To determine the probability distribution of x, we need to calculate the probability associated with each possible value of x, 0, 1, 2, 3, or 4. In this case, the probability distribution would follow the binomial distribution. The binomial distribution describes the probability of a certain number of successes, tails, occurring in a fixed number of independent Bernoulli trials, coin tosses, where each trial has the same probability of success, 0.5 for a fair coin. To calculate the probabilities for each possible value of x, we can use the binomial probability formula. P x equals k equals c n k asterisk p caret k 1 p caret n k, where p x equals k is the probability of x taking the value k, n is the number of trials, 4 coin tosses, k is the number of successes, number of tails, p is the probability of success in a single trial, 0.5 for a fair coin. C n k represents the binomial coefficient, which calculates the number of ways to choose k successes from n trials. C n k equals n k n k. Using this formula, we can calculate the probabilities for each value of x. P x equals 0 equals c 4 0 asterisk 0.5 caret 0 1 minus 0.5 caret 4 to 0. P x equals 1 equals c 4 1 asterisk 0.5 to the power of 1 asterisk 1 minus 0.5 caret 4 to 1. P x equals 2 equals c 4 2 0.5 to the power of 2 asterisk 1 minus 0.5 caret 4 to 2. P x equals 3 equals c 4 3 asterisk 0.5 to the power of 3 asterisk 1 minus 0.5 caret 4 to 3. P x equals 4 equals c 4 4 asterisk 0.5 to the power of 4 asterisk 1 minus 0.5 caret 4 to 4. The resulting probabilities would be p x equals 0 equals 1/16 p x equals 1 equals 4/16 p x equals 2 equals 6/16 p x equals 3 equals 4/16 p x equals 4 equals 1/16. Therefore, the probability distribution for variable x, which represents the number of tails in 4 tosses of a fair coin, follows a binomial distribution. This distribution is justified because the experiment involves a fixed number of independent trials with the same probability of success, 0.5 for a fair coin. What are different types of probability distribution? There are several types of probability distributions commonly used in statistics and probability theory. Some of the main types include uniform distribution. In a uniform distribution, all outcomes or values have an equal probability of occurring. It is characterized by a constant probability density function, PDF, over a defined interval. Examples include rolling a fair die or selecting a random number between A and B. Normal distribution. Gaussian distribution. The normal distribution is a continuous probability distribution that is symmetric and bell-shaped. It is widely used due to the central limit theorem and describes many natural phenomena. It is defined by its mean and standard deviation. Examples include height and weight measurements in a population. Binomial distribution. The binomial distribution represents the probability of a certain number of successes, or, yes, outcomes, occurring in a fixed number of independent Bernoulli trials, where each trial has the same probability of success. It is characterized by parameters n, number of trials, and p, probability of success in each trial. Examples include flipping a biased coin multiple times or counting the number of successes in a fixed number of independent experiments. Poisson distribution. The Poisson distribution models the probability of a certain number of events occurring in a fixed interval of time or space, given the average rate of occurrence. It is often used to model rare events. Examples include the number of phone calls received at a call center in a given time period or the number of accidents at a particular intersection in a day. Exponential distribution. The exponential distribution models the time between events occurring in a Poisson process. It is characterized by a constant hazard rate and is often used to model lifetimes or durations. Examples include the time between radioactive decay events or the time between customer arrivals at a service desk. Gamma distribution. The gamma distribution is a generalization of the exponential distribution and is used to model continuous positive variables. It is characterized by shape and scale parameters and can model various types of data, such as waiting times, insurance claims, or rainfall. Chi-square distribution. The chi-square distribution arises when summing the squares of independent standard normal random variables. It is commonly used in hypothesis testing and confidence interval construction, particularly in the context of comparing observed and expected frequencies in contingency tables. These are just a few examples of probability distributions, and there are many other distributions with different characteristics and applications. The choice of distribution depends on the nature of the data and the problem being analyzed. Thanks for watching. Please like, share and subscribe.